Another way of describing relative position is through the use of a percentile. And you've probably encountered percentiles in your life. When you were young, you may have been in a particular height and weight percentile. If any of you have had kids already, one of the things that your doctor always shares with you at the different checkups is what percentile your child's weight or height is in. If you've taken a standardized test like the ACT or the SAT, you were given a percentile. So what do those percentiles actually mean? Well, imagine that you were to divide up your data set into 100 parts. Then your Rth percentile, which could be the 10th percentile or the 30th percentile or the 99th percentile, that is the value in your distribution where that percent of the observations lie at or below your value. So let's say that your child was in the 75th percentile for height. That means that your child is taller than 75% of other kids that age. They are 75% taller. They're 25%, or they're shorter than 25% of the values. So the percentiles are always giving you the percent below that value. Sometimes we do want to answer being above that value, and it's always just 1 minus that percent. So percentiles are a great way for you to describe where within a data set a particular observation would fall. So here you can see if you're in the 75th percentile, you would write that P with a little 75. 75% is below that, and 25% is above that. And for these percentiles, you do not have to be in any particular distribution. It doesn't have to be normal. It doesn't have to be symmetric. This will hold for any distribution because you are comparing within this distribution. Now, we've talked about the median, and the median is the 50th percentile because 50% is below that value. Our quartiles also are percentiles because the Q1 was the 25th percentile and Q3 ends up being the 75th percentile because 25 or 75% respectively of observations fall below those values. So how do you compute a percentile? Well, you do need to have a little formula, and this is going to be another one that we can do in JUMP, but JUMP is going to give the more precise way to do this, and we are going to use a little bit more of an approximation here. So we'll arrange our observations from smallest to largest, and you can use JUMP to help you with that. But to find a particular percentile, you will need to use this formula where you take the number of observations, multiply by the percentile that you want, and divide by 100. If you end up with a whole number, then you're going to take that number and the next number and add them together and divide by 2 to get the mean value. If you're not a whole number, simply round up to the next whole number and find your position. So it's really just like finding Q1 and Q3, but here you have to do n times r divided by 100 to figure out the position that you're going to go to. So I'm going to show you in JUMP how to do this, as well as how we would get the answers for our homework. This data set is giving the length of time that it takes people to walk across the Brooklyn Bridge. And typically it takes people between about 45 and 60 minutes to walk across the bridge. And here we do see that there's some variation there. So if we wanted to find the percentiles, we certainly could analyze the distribution where we're getting almost all of our summary statistics. And from here, we get these quantiles that are default, so 2.5, 10, these are all percentiles. But what if we want different percentiles? So if you go to your display options, you can actually customize your quantiles, or percentiles in this case. Now, you are going to need to do these as a decimal. So if you want the 20th, the 50th, the 75th, the 80th, and the 95th percentile, give them as a decimal and say okay, and then you're going to get these custom quantiles. And here it's just giving you the values that would represent these different quantiles. So don't worry about this other stuff. That is something we will get into later in this course. But for right now, these values, and you see that the 75 did match up with the Q3, the 50 matched up with the median, and that's how you can get any of the different quantiles or any of the different percentiles that you want. However, this is not going to be the way that the Tukey method that our textbook uses. So how would we do the textbook method? Well, let me close these out. And remember when we were doing our quartiles, we sorted our distribution. So we sort ascending. I'm going to see if I can't delete these. Oh yes, so highlight these rows that you don't want and just right click and delete. And now they're gone. Okay, that's much better. And so we have our data sorted and we want to figure out different quartiles. So let's do the percentile. Let's do the 20th percentile. So the formula says that we take our sample size, which here is 30, and we want our 20th percentile. So we multiply by 20 and then divide by 100. So that tells us that we need to look, we get a 6 for our answer. And since we did get a whole number, we need to take the 6th and 7th observations and get the average. So that's 5 and the 6, sorry. 6th and 7th. So, it's the sample size times the percentile divided by 100. If you get a whole number, you take that observation and the next observation and do an average. So 33 plus 34 divided by 2 gives you 33.5. So that's the way that you're going to need to do your percentiles for your homework, but definitely use JUMP to help you sort your data and also to identify the position of your data. It's nice to have the column labeled with which position, but use that little simple formula to help you figure out where you're going to get your percentiles. Let's say that I wanted to get the 45th percentile. So here I would do 30 times 45 divided by 100. There I got 13.5. Well, I could go ahead and round up to 14, and I could say that the 45th percentile is there at 44. Now remember, these percentiles are giving you the percent below. So we can say that 45% of the observations are below 44. That means that 55% of the observations are above 44. And so that is how we can talk about relative position in terms of the percentile.